Hello students, welcome to this math video tutorial on the area supernote, part 6. We're looking at section F, area of composite figures. Any composite shape can be broken down into recognizable shapes. So a composite just means a combination of different parts. So if we look at this shape, we see that it is an irregular shape. We don't really have a formula for the area of this type of shape. So what I've done is I've kind of enlarged it so that we can kind of have two different strategies here. So if we were to have, let's say, a pair of scissors and we were to cut this shape into two, because we want to make the minimum amount of cuts, because the more cuts we make, the more area calculations we have to make. So there's a couple of obvious strategies here. So if I look at strategy 1, we'll call this strategy 1. Okay, I can use my scissors and I can cut this shape across right there. Therefore, I've created, it looks like, maybe a square or a rectangle, and this one probably looks like a square or a rectangle as well. So if we have this strategy, let's see what kind of measurements we have. Now, the thing that makes this one challenging is that there are some missing measurements. Okay, so let's look at this long part down here. So we know that this is going to be 10. Okay, this side we don't know, and this side we don't know. This we know is 4 centimeters. This top we know is 6 centimeters. Now this figure here of 12 centimeters doesn't really help us on this side because we've chopped that 12 centimeters into 2. So if I know that from here to here is 12 centimeters, and I know that from here to here is 4 centimeters, then how would I go about finding what this is, or this length here? Any ideas? All right, so we take this total length of 12 and then we subtract the shorter length of 4 to give us 8. Okay, so now we have here a rectangle of 10 by 8. And then here we have a rectangle of 6 by 4. Okay, so let's go over to the next diagram here. And sometimes there are more than one strategy. So if I look at this shape again, I can see that if I had a pair of scissors and a ruler, I could cut straight down here. Okay, let's call this strategy 2. So let's fill in what we know. Well, we know that this is 6 centimeters. We know that this is 12 centimeters. We know that this is 10, but that's not really going to help us right now. We know that this is 4, but that's really not going to help us. So we know that one of these rectangles right here is 12 by 6. So what we need to do is we need to find out what this is. Now, we already know that this is 4. So because we've already worked on strategy 1, we know how to solve for this, right? We have 12 subtract 4 gives us 8. Now how about this little piece here? This is a mystery. So we know that this length right here is 10. Oops, sorry. And we know that this length to here is 6 because that's this side up here. So then how would I go about solving for this? Well, it is 10, this distance, subtract 6, which is this distance, and that gives us 4. So it looks like we have a rectangle here of 4 by 8, and we have a rectangle here of 12 by 6. Now we can use either of these two strategies and we should get the same answer. So what I'm going to do is I'm going to use strategy 1. I'm going to call this rectangle 1. I'm going to call this rectangle 2. Okay, so let's begin. So, first part of our solution, area of rectangle 1 equals. Well, if we remember, the formula for area of a rectangle is base times height. So, what do we know about the base and the height? Well, they are right here. So the base is the longest side. So the base is 6 centimeters. The height is 4 centimeters. Next is our substitution line. Area equals, what's the base? 6 times what's the height? 4. Our answer line, area equals 24 centimeters squared. Okay, so that takes care of this area right here. All right, now let's solve for the area of rectangle 2. So I'm just going to make sure that I'm separating all my work so that it's very easy to understand. Part of communicating your knowledge is making sure that your answer is easily read. All right, so again we have another rectangle because these two sides are different. So let's start with our formula. Area of rectangle 2 equals base times height. Well, let's look at our two measurements. What are our base and what are our height? The base is 10 centimeters. The height is 8 centimeters. We look at our formula. We substitute. Area equals 10 times 8. Using our calculator or maybe mental math, you get area equals 80 centimeters squared. Okay. Well, I'm not finished, right? I still need to do one more step, and we'll call this step 3. And just so that I'm kind of showing all of my steps, we'll write here area total, T-O-T, total, equals, well, we take the area of our first rectangle, 24 centimeters squared, and then we add it to the area of rectangle 2, which is 80 centimeters squared. And using your calculator, I got 104 centimeters squared. So notice that for each of these steps, we didn't put a final statement because now is the opportunity to put the final statement. Therefore, the total area of this shape or figure or whatever you want to call it is 104 centimeters squared. So I hope you got that strategy, is that whenever we're faced with a complicated shape, all we have to do is we have to think of ways that we can break that shape down into shapes that we're familiar with. So let's go on to example 2, which looks a lot more complicated, but there are some recognizable shapes right there, aren't there? So first of all, I'm looking at this shape, which is pretty obvious right here. Okay, that looks like a triangle. And then this shape that's kind of piled on top of looks like a parallelogram. Okay, so let's start here. So we'll start with part 1 of our answer. Area of a triangle equals, well, if you remember, base times height divided by 2. Okay, so what I'm going to do is I'm going to draw a little diagram of that triangle. I have a feeling I'm going to need it. Okay, so what I know is I know this measurement, but I don't know the base. So how do I solve the base? Well, if I look at my diagram, if I extend this line, I know that this measurement here is 7 millimeters. And then if I fill in the parallelogram underneath, I know that this is 42 millimeters. So if this distance from this point to this point is 42, and I know that this little section is 7, how do I go about solving for this? Well, it's going to be 42 subtract 7, isn't it? And somewhere in your answer, I need you to show me that you understand how to get that. So 42 subtract 7 is 35 millimeters. So that is going to be the base of our triangle. Perfect. All right, so the base is 35 millimeters, and our height is 21 millimeters. Okay, so the rest of this part of the calculation should be straightforward. Substitution line, area equals 35 times 21 all over 2. Base is 35, height is 21. So using your calculator, please solve for that. So 35 times 21, what'd you get for it? I'm just taking my calculator out here. 35 times 21 equals 735. So we have 735. And don't forget, we still need to divide by 2. So that's going to give us our answer line. So 735 divided by 2, using your calculator, is 367.5 millimeters squared. Okay, so that's the area of the triangle. So now let's look at this shape down here. Okay, so I've got a height, looks like, of 10, and I've got this base here. Now I'm given this measurement here, 15 millimeters. Does that help us in any way? Well, no, it doesn't, because we're given the height here, and this is all we need to know in terms of a parallelogram. Okay, so let's start part 2 of our answer. Area of a parallelogram equals, do you remember the formula? Base times height. Substitution line, base equals 42 millimeters, height equals 10 millimeters. Remember, we already determined that this measurement is not needed. It's unnecessary. Substitution line, area equals 42 times 10. Now, hopefully you don't need a calculator for this. Area equals 420 millimeters squared. Oops. Okay, so we have our 2 separate shapes, here and here, but we're not finished, are we? We need step 3. Area total equals, let's take our first shape, the triangle, 367.5 millimeters squared, plus the second shape, which is the parallelogram, 420 millimeters squared. Using your calculator to add them up, I got 787.5 millimeters squared. Now we write our final statement. Therefore, the total area of this shape or this figure is 787.5 millimeters squared. Okay. Now think of the endless possibilities of the amount of shapes that we could combine together to form composite shapes. Okay, this concludes this tutorial, and that's the last section on the area supernote. You survived it. Thanks for watching. Bye.